I have here in front of me the homepage of Cadence. Cadence is our online tool for visualization of transport models and GIS data. You can follow along at home by going to dat-stats.cityscience.com. Here I'm signed out, so on the screen you can see exactly the same here as what you can see if you went to the page yourself. Here there's shortcuts to showing off many of the different features of Cadence, and in the top left we've got links to our models, the help pages, and the changelog of recent features. If we jump to the Explore page, we can see all of the models we have access to while signed out, and we'll jump into our demo model of Exmouth, just a town in Devon. Here's the project folder of the model with all of the different files for the model and its GIS data in a regular folder and file structure. Here you can see the history of the project as well as the areas being worked on at the moment. By hitting the Open Stats button, we can go to the visualization of the different variants of the model. Diving into the routes page, we can see accessibility measures across the model. Here, as our base map loads up, we can see our dropper, which is showing the location traveling from the model to the cost of traveling to every other location in the model. And in the top right, we have a histogram where we can filter in to see what links are within what distance band of the dropper. The dropper works in both from and to direction, and it can show a number of different metrics, including distance, time, and generalized cost for each of the user classes. And as a general useful value, we can also see the demand flow, which is what is influencing some of those travel times. So far it's all been static, but we can, as well as looking at the UFS data, we can also calculate on the fly. To do this, we need to basically create a scenario with the changes we're looking for. And to do this, the first scenario, we shall look at the road safety data. Here's the Stats 19 accidents for the area, which is provided as a standard layer for all of Cadence projects. So your projects in here will also have access to these standard data sets. With this on, you can see a cluster of accidents along Exmouth High Street. So for our first exercise, we'll look at what would happen to traffic flows if the high street was closed to vehicular traffic in both directions. You can see here the band links showing up, and there's also the facility to band links by typing in the ID of the link as well. Hit the Calculate Costs button, and we will run an assignment of these flows. For the sake of speed, that was an assignment rather than a full simulation assignment. And now we can see the difference in travel times. We can see the difference in flow as a result of that. If things aren't so clear, it's especially true of the much larger models, we can turn on ISIC bands, which kind of shows the clustering effect around the links, not just on the links. Not just for demand flow, but we can also show how the access for travel times have changed. We can place the dropper on any link in the model and see how that access has changed. We can see the baseline value as well as the scenario value we've just calculated, as well as the difference between the two, showing areas in green where travel times have improved, and areas in red where access times has got slower. As you can see, it's in the histogram that there are some areas which have improved access and others which have got slower. The second scenario we're going to show off is looking at housing. Again, for contextual information, we can turn on some land use values and look at the sites of current construction within Exmouth. Using the housing tool, we can drop additional demand onto the zones near to both those construction sites. Here we can also change the number of houses which are being considered, and with this again, hit the calculate costs button and we can see the impact of adding housing. And there we go, an increase in travel time across the network. Moving the dropper, we can compare one area with another and see that some locations do have some improvements in access or worse access to other areas. By looking at the demand flow, we can also see that this is in part due to how flow has to some extent been rerouted along different routes. The second what if tool I want to show off today is in the network page. Here we can dive into a junction and look at changing some of its properties and seeing what wider impacts it has. Using the cross filter, we can very quickly filter down to the only 4-arm signalized junction in the model and then look at its source data here and diving into a junction view here. Here we can see both as a set of turning diagram and as a turning matrix all the different properties in the model alongside the source data for that junction. Turning on the simulation mode, it's now interactive and we can see how trips arrive over the light cycle and how trips leave over the light cycle for all arms, one arm, or a single turn. Not just the flows, but we can also see how queues build and dissipate over the cycle period. And more than just seeing the characteristics of the junction in that way, we can also change the values of any attribute in the model by shifting around the light timings. We can rerun the simulation, seeing what impact that has. Not just the junction characteristics we can change, but we can also change the arrival profiles to change at what period of time over the light cycle does trips arrive from the neighbouring junctions. We hit update, it has that new arrival profile. So as you can see, this makes a great interactive debugging tool where we can see the impacts of changing the junction coding, how queues build without having to run an assignment of the entire model to deal with those stubborn junctions which are hard to debug in the model. Thanks very much for listening to this video. We have live demos of Cadence running at our booth throughout the day, as well as a program of seminars and workshops throughout the day to basically make our booth more interactive. So please do pop on over to our booth and say hello. Thanks very much for listening.